guys! In today's video, we're going to talk about curved mirrors. More specifically, we're going to go over concave mirrors and convex mirrors. I'm also going to talk about plane mirrors as it's easier to describe what's actually happening. We're also going to go a little bit into diverging and converging lenses. Okay, so to start this off, we're going to go over a plane mirror. This is just to show how a light of ray reflects off of a mirror. So this is our plane mirror, and that is just the normal mirrors that you will see when, going into the washroom, or just the ones that are hung up on a wall. This doesn't distort the image at all and replaces basically an identical version of it. Now, what's actually happening, right, is we have our light ray coming in and hitting the mirror. This light ray is called the incident ray, okay? Now, when drawing one on a diagram, we add an arrow to show which direction the light ray is going in. Now, to figure out how it reflects, we're going to draw a line here. This line is going to represent something called the normal. Now, the normal is always perpendicular to the mirror. That means that there is a 90-degree angle right here. Now, to figure out where this ray comes out on the other side, aka the reflection ray, we have to first measure the angle. Now, we can either measure this angle or this angle. Both work, but you have to do them in different ways. If you measure this angle here, you have to replicate that angle on this side. If you measure this one here, you have to replicate it over here. Now, I'm going to measure this angle here. I'm going to show you how to do this, so I'm not just saying words, because this one makes more sense to me. Now, using our protractor, I'm using a dry erase marker, so it's not going to be as perfect as it should be, but I'm getting about a 50-degree angle. So on this side, I'm also going to put a 50-degree angle. So that is 50 degrees in here, right here, okay? So this 50 degrees should line up with the corner here. Okay, now that means that these two angles are the same, and these two angles are the same. We're going to draw our arrow. Now this is the reflection ray. Some very important concepts I want to go over within this is the angle of incidence, right here, I. And this is the angle of reflection. Like I have previously stated, the angle of incidence is equal to the angle of reflection. Okay? That's actually pretty much it with the plane mirror. But what if things got a little bit more complicated? And what I mean by complicated is the image gets distorted. Well, this can only happen in one of two ways. The first one is called a concave mirror. And this is when the mirror is bent around the object. So this is like a spoon. Okay? This here is the ground, and this is our mirror. It's a little bit off center. Forgive me for that. Right here is our first point, and we're going to call this the focal point. And this is the center. Now, the focal point is where all of the light is going to focus itself. It's in the name. And the center is where the center of the circle would be if it were to be continued. Now, this, like I previously stated, is a concave mirror. I like to remember concave mirrors by the way that it opens up here. To me, it looks like a cave, a concave, because the object is going to be here, and it kind of looks like it's going around the object, a door. It's this way, right? Okay. This is the same kind of mirror as a spoon. You can think of it that way too. Concave. Now what we're going to do is I'm going to draw an object. In this case, our object is going to be an arrow. Now, what I want to show you is how to get the reflection on this diagram of what that arrow would be. The first thing we're going to do is we're going to draw a line from the top of the arrow to the mirror. This is going to be perpendicular with the ground. We're now going to take that line and bring it through the focus point. Now we're going to start a second line and go from the top of the arrow again but this time immediately go through the focus point. We're going to go until it hits the back of the mirror, or till the mirror. Now we're going to bring that mirror, again, perpendicular to the ground until it hits the original line. In this case, it is this point right here. Now we're going to draw our reflection. Now this is really not that accurate because of how thick my marker is, but we can imagine it kind of looks, well, there we go, we can erase this here. That is our reflection. Now we want to describe this reflection. How we're going to do that is first we're going to talk about the size. It's kind of hard to tell with this diagram, but I'm pretty sure it is larger. We're also going to talk about the attitude. Now, the attitude means how it is oriented. So, if it is upright, it is facing upright relative to the ground. And if it is inverted, it is upside down relative to the object. So, it'll be the opposite way of the object. In this case, it is inverted because it is upside down. Next, we're going to talk about the location. There's a few places where this could be. It could be from here to here. It's beyond C because the C is the center point. From here to here, where our reflection is, it is between C and F. Now from F to the mirror, it is beyond F, or between F and the mirror. And then behind the mirror, it is called virtual. Now this means that it is behind the mirror and inside of the mirror is the reflection, which is kind of neat. But in this case, our location is between C and F. The last thing we're going to use to describe this is the type. Going off of what I just said about real and not real images, if it is located behind the mirror, it is virtual. If it is on this whole side here, it is real. Now, what if it was convex? AKA the other way of having a bent mirror. In this case, the mirror would be bent away from the object. When I'm getting this set up, what do you guys think of the new setup? It's not permanent. I stole it from my dad, but I think this is a great way to be able to draw more close up and just show what I'm trying to actually talk about. Looks a lot more professional, doesn't it? Convex mirror, I like to remember as the opposite of a concave mirror, because, you know, there's only two. Convex. Okay, so there's a lot of the same similarities between these two. Again, we're going to have our focal point and our center point. Now, we're still going to have our object on the left side. The only difference is the mirror is facing away from it. It is curving away. Now, how we're going to figure out our reflection this time is first repeating the same step by drawing from the top of the object to the mirror. Then we are going to bring this line down and through the focus point. Making sure the video is still on because I accidentally stopped it around here last time. I don't know how. Anyway, bring the line down and through the focus point. Next, we are going to draw a line from the top of the arrow immediately going down towards the focus point. But this time, we're going to stop. Well, we did last time too, but we're going to stop at the mirror. And now we're going to draw a line perpendicular. No, parallel to the ground. But out until we hit this point here, where these two lines meet. Okay, so now that we know where these two lines meet, we can bring our arrow to that point. This decides how tall it is. So now we have a reflection. Again, we're going to describe it using the same ways. The first one is size. In this case, the size is smaller. We're also going to go by attitude. This is the orientation, and in this case, it is upright. Next, we're going to talk about location. Now, this one is between F and the mirror. F and the mirror. And then we're going to talk about the type. Now, this image is behind the mirror or inside of the mirror. So it is a virtual, I think I spelled that right, a virtual image. Now, before I end this off, I want to go a little bit into diverging and converging lenses, because we're also talking about light rays and they're kind of similar. So, a diverging light ray, whoa, that's not how it goes. A diverging lens is like two concave mirrors stuck together. So again, this is our ground. Ooh, I could use the protractor, I think. Let's do this, shall we? Okay. Haha. Haha. So two. Ooh, that didn't work out as well as it should. Okay, anyway. Two concave mirrors. In this case here, this is our mirror, okay? This is both outside of the mirrors. Now, because there is two, we're going to have two focal points. Okay? That just makes sense, though. In this way, if we had an object here, right? Like, well, an object would be here. But what happens to light when it goes through here is it gets hit, right? Light beams go through. And then they come out like this. This is why in a funhouse you may appear larger or smaller, because it distorts an image. Now, going into a converging lens. So that was diverging. A good way to remember that, though, is it disputes the light, distributes. Yeah, so diverge to distribute. This is a converging lens, which is like so. Kind of looks like an oval. Ha. In this case, we also have two focal points. So, with our object, in this case, we're going to use, oh my god, I'm saying that a lot, sorry. We're going to use an arrow. How we're going to figure out our reflection is we're going to bring a line from the top of the object to the mirror, and then we're going to bring it down through the focal point. We're going to make a second line going down through the original focal point, so the focal point on this side, and stopping when we hit the mirror. And then we're going to draw a straight line that is parallel with the ground across until we hit the point. And then, as we have done previously, we make our our reflection relative to that point. To describe this, the size I think is smaller, but my marker is a little bit big. The attitude is inverted. The location, okay, so location is a little bit weird with this because it is between, it's weird because these are both real, okay, because this is the mirrors. These are both real, so the location I would say is like between F and C or beyond F. Because it's not behind the mirror. I know it might look like that considering the other cases we've had, but the mirror ends here. Similar with our type, it's not virtual, even though it is on that side of the mirror, because the mirror ends here, meaning it is real. I know that got a little bit confusing, but that is all I have on the different types of curved mirrors in a diagram. Thank you for watching. Rock on.